All right, so get this. You sent us some research, and it's about supercharging visual reasoning skills
Oh, wow.
for multimodal large language models.
MLMs.
MLMs, that's right, for those in the know.
Yeah,
We're talking AI that can solve tricky visual problems, especially in math. I know you're interested in that.
absolutely.
It even delves into System 1 versus System 2 thinking.
Heady stuff.
Pretty heady stuff. You won't believe how this new technique uses thought cards to boost AI performance.
Interesting.
It's like giving the AI a cheat sheet for problem solving.
So what's really exciting is that MLMs are already doing some amazing things.
Right.
But when it comes to that complex reasoning that you need to, say, solve a geometry problem
Uh-huh.
with a diagram, they struggle.
Yeah.
So we're really trying to bridge that gap.
Okay, so we're not just talking about AI recognizing images,
Right.
but actually understanding and reasoning about them.
Exactly.
What kind of real-world impact are we talking about here?
Well, think about it. Faster, more accurate medical diagnoses.
Okay.
Through AI analyzing images, robots that can navigate complex environments intuitively, even educational tools that are personalized to a student's visual understanding.
Wow.
The potential is enormous.
This is groundbreaking stuff.
Yeah.
But how do we even begin to train these MLMs for such complex tasks?
Well, there are two main approaches that are being used now.
Okay.
Explicit search and teacher-guided training.
Okay.
Explicit search is incredibly thorough, but it can be computationally expensive, as it explores a vast number of possibilities.
So it's kind of like brute force.
It is like trying every path in a maze.
Gotcha. And teacher-guided training, does that mean we're essentially hand-holding the AI through the learning process?
In a way, yes.
Okay.
It's like providing the AI with a textbook and a teacher.
Yeah.
However, it requires massive amounts of data and computing power, which can be limiting, especially in specialized fields with limited data.
So both methods have their drawbacks.
They do.
Is there a way to combine the strengths of both approaches?
That's where AStar comes in.
Okay.
It takes a completely new approach to this problem.
This is where things get really interesting.
It does.
Tell me more.
AStar is automated, meaning it can identify its own reasoning patterns without explicit step-by-step instructions from us humans.
Okay.
And get this, it does all this with limited data and less computing power.
That sounds almost too good to be true.
I know, right?
Are there any tangible results to back up these claims?
Oh, the results speak for themselves. AStar has demonstrated remarkable performance, even surpassing models like GPT-4o on certain benchmarks.
Surpassing GPT-4o.
Yeah,
That's a bold statement.
it is.
Can you give us a concrete example of how AStar works in practice?
Sure, let's take the MathVision benchmark,
Okay.
which tests AI's ability to solve math problems involving diagrams.
Uh-huh.
AStar employs these thought cards, which are essentially pre-made reasoning templates.
Okay.
They act like a cheat sheet, allowing the AI to process information and solve problems more efficiently.
So instead of starting from scratch every time, AStar has a toolbox of proven reasoning strategies at its disposal.
Exactly.
Clever. How much more efficient is AStar compared to other methods?
Well, the research shows that AStar requires 6.4 times fewer computations than comparable methods to achieve similar or even better results.
Wow.
Imagine the implications. AStar could be deployed on devices with limited processing power, like your smartphone, bringing advanced AI capabilities to everyday applications.
Well, that's a game changer.
It is.
We've touched upon these thought cards a couple of times now.
Yeah.
Could you elaborate on how they are created and how they actually aid the AI in problem solving?
So these thought cards, they're like a concentrated library of reasoning patterns.
Okay.
They're derived from a small set of training data using a method called Monte Carlo Tree Search.
Uh-huh.
This is a systematic way for the AI to explore various reasoning paths and learn from both its successes and failures.
So it's like the AI is playing a game against itself
Exactly.
to figure out the optimal way to think?
Yeah,
This is fascinating.
it is.
But how do these thought cards come into play in a specific scenario? Let's say the MathVision benchmark you mentioned.
Okay.
Can you walk us through a real-world example?
Sure. Imagine AStar is presented with a geometry problem that involves calculating the area of a complex shape.
All right.
First, it uses its visual parsing abilities to identify the different elements of the diagram, like circles, squares, and triangle.
So far, so good. The AI is recognizing the visual elements.
Right.
But how does it bridge the gap from recognition to actually solving the problem?
Right.
That seems like the real hurdle.
It is.
Right? It's one thing to see the pieces, but it's another to know how to use them.
Exactly.
So how does AStar figure that out?
Well, that's where the thought card come in.
Okay.
Let's say one thought card suggests breaking that complex shape into smaller, more manageable ones,
Uh-huh.
like a classic divide-and-conquer approach.
So the AI is learning to apply strategies.
It is. It's pretty impressive.
That is impressive.
Another thought card might suggest looking for relationships between those shapes. Are there parallel lines? Are there right angles and so on?
Yeah.
By applying these pre-learned patterns, AStar systematically works through the problem.
That makes sense. It's like having a mental toolkit to tackle the problem strategically.
Yeah,
But what about those curveball problems, the one it hasn't encountered before?
right.
Can AStar handle those too?
That brings us to another exciting aspect of AStar,
Okay.
out-of-distribution generalization.
What?
Essentially, it means AStar can tackle problems it wasn't specifically trained for.
So it's not just a one-trick pony. It can actually adapt.
Precisely.
And learn.
The research even shows AStar tackling a Chinese exam
Whoa.
with history, geography, and science questions.
Hold on. A Chinese exam, so it's not limited to just math and geometry.
Yep.
It can understand different subjects.
Yeah.
And languages.
This ability to generalize knowledge across different domains, even languages, highlights AStar's incredible potential.
Yeah.
It could revolutionize fields that rely on visual problem solving, like engineering architecture or even urban planning.
It's like we're seeing AI evolve beyond just mimicking human intelligence to something closer to actual understanding.
Yeah, it's not just about speed or efficiency anymore.
Right.
It's about that adaptable, creative thinking that we associate with humans.
That human element is where this research gets really fascinating.
It does.
Remember our earlier discussion about System 1 and System 2 thinking?
Uh-huh.
Well, AStar seems to exhibit a similar kind of adaptive reasoning.
Exactly.
You mean adjusting its approach based on the problem's complexity?
Exactly. There's a fascinating parallel with a visualization study.
Okay.
Researchers observed that AStar's thought space, the range of reasoning strategies it considers, becomes more diverse and complex when given more thought cards.
So like us, when we hit a roadblock, we brainstorm more possibilities, explore different angles. AStar does the same.
That's the idea. It's not about rigidly applying a single thought card.
Right.
It's about evaluating the problem and choosing the best strategy, maybe even combining several.
This is mind-blowing, but let's bring it back to you. I know you're interested in the listener's field of interest.
Yes.
How could AStar impact that field?
Well, let's consider the possibilities. Imagine having an AI that not only processes complex visualizations, like in financial data or scientific models, but also extracts meaningful insights and presents them in a way that's easy to grasp.
That would be huge.
It would.
No more getting lost in spreadsheets or dense reports.
Exactly.
What else?
AStar could also be a game changer for fields like engineering architecture or urban planning.
Okay.
Think about designing efficient transportation systems or creating buildings that are both aesthetically pleasing and structurally sound,
Yeah.
all with the help of an AI that can see and think spatially.
This isn't just hype. AStar has the potential to fundamentally change things.
It does.
But let's be realistic. This research is still in its early stages, right?
Absolutely. There's still much to explore and refine. It'll be exciting to see how AStar evolves as researchers continue to push the boundaries.
So where do we go from here? What are the big questions researchers are wrestling with?
One that immediately comes to mind is how to make these thought cards even more robust and versatile.
Okay.
Currently, they're primarily derived from human-generated data.
Uh-huh.
What if AI could create its own thought cards based on experience?
AI generating its own reasoning strategies?
Yeah,
That's next level stuff. Like we're giving it the tools not just to learn, but to learn how to learn.
exactly.
Which raises another question. If AStar can adapt based on complexity, could we one day have AI that truly understands the nuances of human thought? Could it even teach us new ways of thinking?
Now, those are questions worth pondering. As AI becomes increasingly integrated into our lives, we need to consider not only the practical implications, but also the deeper philosophical ones.
I couldn't agree more. And that's what I love about these deep dives. We're not just skimming the surface. We're getting to the heart of why these advancements matter. I think we've covered a lot of ground today.
We have.
From the nuts and bolts of how AStar works to the mind-blowing possibilities it opens up. But
Yeah.
I think the biggest takeaway here
Right?
is that we're seeing a real paradigm shift in AI.
I think that's a great way to put it. AStar isn't just a small step forward. It's a fundamental change in how we approach AI, particularly when it comes to visual reasoning. We've opened a door to a whole new world.
And it's a world that you, our listener, are a part of. Remember, this deep dive was inspired by research you sent us.
That's right.
Your curiosity and insights are what fuel these advancements.
Absolutely. We encourage you to dive deeper into the source material we've discussed today. Explore the intricacies of AStar. Consider its potential in your own field. And most importantly, keep asking questions.
That's what the deep dive is all about.
It is.
Sparking curiosity, fostering deeper understanding, and empowering you to become active participants in this ongoing conversation about technology innovation and the future we're building together.
We're constantly amazed by the insights and questions we receive from our listeners. And we can't wait to see what you uncover as you continue to explore the frontiers of knowledge.
So until next time, keep learning, keep questioning, and keep diving deep.